You can see everybody on your screen, CIMCO Verify Machine Simulation. That's what we're here for. Who uses CIMCO? It's very easy. What we're going to show today is going to be one of two users. You're going to be either the programmer trying to make sure that, A, you can make your program, you can get as fast as you can programming. It doesn't do any good to spend 50 hours programming if you could do it in 40. And then we even have a solution for the guy on the floor who's taking old legacy programs or validating what the programmer sent him is going to run good on the floor. So we're going to go back and forth between the two and show use cases for both of them. Products. When it comes to products, we know they're all under CIMCO. We sell and support CIMCO. We asked Ryan as a favor to come in here and help us sound smarter than I am. We're going to showcase three things primarily: CIMCO Edits Verify. We're going to cover the CIMCO Edit product itself, and then we're going to show G&M code simulation through the machine module add-on for the edit. So while this is running in the background, just to kind of whet your appetite of what's possible, we took a couple of side-by-side videos. For most of us who've programmed a job, we always run it through a verify real quick in Mastercam to make sure, well, is it doing what I really want it to do? Just a quick eyeball test, right? Make sure we didn't have some big red line sweep through our part where we wiped out part of the actual features themselves. So on the left-hand side of the screen, CIMCO Verify running. Over here in Mastercam, if you look at the little bar down at the bottom, it's still processing. At the end of this, we're going to get a chance to see what we have verify time in one software versus verify time in the other.
Yeah, one other thing to add to that as well, Jason, is at least I know as myself as a programmer, I didn't just get verify dialed in on one time. I would find myself, after maybe every operation or every couple, jumping into verify and then also refreshing the graphics as well. So I just picture 21-minute time to wait every single time I want a verification. It certainly adds up and adds up very quickly too.
100%. Let's take a look also. This is that same part, but we're going to run it through. Most people here, if you've bought a post from us, we've given you the option for a simulation. The module works driven simulation through Mastercam, and even now with some of the newer technology, we'll use an external post where we'll take the centerline code, run it through the post, feed it back into simulation. Still not true G&M code. It's a lot closer than it comes direct out of Mastercam, but it's still not the actual G&M code itself. On the left-hand side, we actually took the posted code. We hit post at both at the same time. We got through posting and through full machine simulation using G&M code on the CIMCO side. And here we are 15 minutes in using the module works driven simulation produced straight out of Mastercam. So again, back to what Ryan's saying, as a programmer, maybe it's not the end of the world if you have to do it once, but I'm guilty of it, like most of you guys, where I'm testing every single toolpath. And if you aren't disciplined to have a starting stock or a stock model or an STL, previous toolpaths, you're going to spend a lot of time. So we're going to cover three things. We're going to use three different models to showcase three different actual uses. We're going to cover a quick and easy part where we're going to show the how do I blank, right? We're going to walk you through the standard process. You can actually watch Ryan set the job up. We're going to move into something that we know blows up Mastercam's verify. We use a mold base that we're going to use a ton of hem stitching so you can really see a practical application. And then we're going to showcase just a standard workflow on a simple 5-axis part. I mean, we want to show the robustness of this part and how easy it can be. And with that, I think, let's see what we've got. Marcus, let's go ahead and introduce Ryan. He's got a slide here, but I'll let you take it away, Ryan. Tell us a little bit about yourself, and I'll be quiet.
Certainly. Yeah, appreciate it. So yeah, Ryan Mermall with CIMCO Software. You may have seen me before. I've done a webinar before on the CIMCO probing side of things. So, but obviously, I appreciate the opportunity to come back and talk to you guys a little bit about our simulation product, both within Mastercam itself, the CIMCO Verify, as we refer to it, but also the standalone product of CIMCO Editor and our machine simulation. models here. So as I said, yeah, we're going to start off, basic and go through, a simple 3-axis part, get into a little bit as far as what would be needed on your behalf in order to set it up and utilize some of these tools, and also some of the integrations that we offer within Mastercam. And then, of course, we'll jump into that 3D mold part as well, something a little bit more complex and is going to take a bit to do traditionally, and then also a 5-axis just to kind of show you the different power and levels of software that we have, of course, being able to kind of do it all. So again, on getting started on something like this, when you go ahead and install the CIMCO Verify, it's going to go ahead and place a tab up on the top ribbon bar for us here, and then simply with that, we're going to have our verification option or a option to do the setup. So if I were to take a look at the setup side of things, we then can go ahead and tell it what the workpiece is, if we have any fixturing on our actual that we want to take into account, but also then our stock as well, whether that's our Mastercam job setup, or we have a natural block or a casting, that we wanted to select as a model, or even a stock model for that matter, right? There's different options here, of course, that we can utilize and set that up. Once we obviously do that, then I could go ahead and do a start to our verification, and you can see it's going to open up as a separate window. So very similar to maybe what you're already used to. That could get stashed on a second monitor if you wish. But with that being the case, we'd be able to either play this through or run it all the way to the end of the part itself. So as you're going in here, there will be a lot of your standard options as far as stop conditions, if you wanted to stop on a collision, or a number of other things too, obviously. So with that as well, if we were to take that to the very end of the part, I could then certainly do different things as far as like a cross section, different zoom windows, or tell it basically my overall quality on how we want to look at that part itself. Again, if I did a comparison, in this case, it's a inch file. So I could say, hey, I want to compare this against, say 5 thou, and start that. And then, of course, that's going to do a stock compare and show me from like an op2 side. Obviously, I have all the undercuts and all the actual stock remaining, where, of course, from a op1 standpoint, I'm not gouging anywhere. Everything, is as expected. Taking that a step further, again, the CIMCO Verify is going to be reading off the Mastercam NCI side of things. But then, of course, because we have the CIMCO editor, which is going to be a true G-code simulation kernel, this allows us to push out all the information from Mastercam by utilizing a CIMCO edit integration tool from within Mastercam. A very similar process is I would go ahead and select on my machine. We would simply tell it, do we want to run this in just a back plotter only, or do I want to pull in the full-blown machine simulation in order to collision check and detect axis limits? Again, a very similar style interface where we would go ahead and set up our geometry so we can push out and save out the information based on the models as far as our workpiece, fixture, and stock. And then, of course, we also can tell it the location in which we wish to save those files. What that's actually going to do is that's actually going to be creating a couple setup files that can be referenced and saved later. And so if any modifications were made to the program itself, or you want to have the shop floor take a look at those files, those can certainly be used from there. Yeah, so if we run through this as well, then obviously we are able to come right into the editor by itself. Again, you may have used us as far as a G-code editor or maybe just the back plotter itself, but needless to say, we could certainly play that through if we wanted to from the start. We could certainly clean this up a little bit too, and turn off like all my rapid moves and everything else, and take a look. In this case, I am doing a machine simulation, so of course I have the actual machine models and everything here. The other thing too that I could do is certainly go to a certain area in the code, and if I click on that particular line, it's then going to show me on the part itself an update to that location as well. So again, we can certainly use these tools in just a backplot only or a full-blown machine simulation portion of it as well. So
Ryan, if you're the guy on the floor, and I'm guilty of this, and I wish I could go back in time and take it back, but as a machinist, I always thought, the programmers, they don't know what they're doing. I'm going to fix their program on the floor and then hope it doesn't blow up. If I go into the NC code and I add 3 spring passes, or I start removing depth of cuts, you can go into the editor and I can go ahead and skip to just the 1/2 inch end mill that does the finishing pass, and I can make sure that that's working just fine.
exactly. Yeah. So if I found in this case, I did modify my code a little bit in order to add a couple extra spring passes, as part of that. There's a couple tools that we offer in order to see that, file comparison certainly being one of them. But, I personally like to actually visualize the part itself. And so that's where we could actually load up those that G code coming back from the floor again, and then take a look at what that is actually doing on the actual part itself, and see those additional spring passes, in action, of course. So it gives you a chance to again double check and see what's actually going on. Make sure they're good changes, either after it's been ran or maybe even before you certainly run it on the machine itself, in order to make sure everything is good to go.
So the CIMCO edit will allow me as a programmer to compare what the guy on the floor ran versus what I posted out.
Of course.
But if I'm the guy on the floor trying to help and I modify the code, I can rerun it through the backplot, or I can rerun it through simulation to make sure that my edits don't blow up the part.
Exactly. You didn't miss a decimal point, a negative symbol, something along those lines, of course. Certainly.
Okay.
Yeah.
This is pretty clear cut, but I would argue that this is an easy part, right? This isn't something that's going to tax your computer and catch it on fire. I was going to say, I was hoping you'd grab that mold file. And I know how long this part takes to verify Mastercam. When it comes to hem stitching, it's a resource vampire, right?
Yeah.
Could you kind of show us a little bit of something like this and what it looks like in the real world?
Yeah, certainly. And I'll just kind of load this up, and we can see the numbers still cranking here, obviously getting, loaded up. And then obviously I could try to get it down to the end, of course. But I'm not going to make everyone wait here and watch this, do it on my computer. But needless to say, the more complex of a part, I would say the more dramatic, you're certainly going to see those differences between. Again, as we saw, a 2-axis or maybe a simple 3-axis part, certainly isn't going to take as long, for instance, traditionally, but maybe where you are getting into some of the heavy other operations, 3D 5-axis, so be it. Obviously, that's where it's certainly going to certainly change how that goes. Again, a very similar setup in something like this, where we can go into the verify setup. I'll just simply make sure everything is good to go, and we could then start up certainly that verification. If we were to get that loaded up, right, we can see that inside of the interface as well. We have our pretty decent, high quality on as part of that. And then in this case, right, I'm just going to go ahead and jump to the very end of the program and let that do its actual simulating of it. It is going to automatically go back through after it calculates and refine and try to clean up the actual image itself. But then again, you can use your standard operations of, stop conditions if it were to detect a collision, your cross-section views if you wanted to check anything, or in this particular case, a stock comparison. This is a metric part, so I'm going to go ahead and change that to 0.1, for instance. And then we can kind of, again, see where things are at, specifically in the radiuses that are going to show, additional stock being left over, of course.
So we know, I appreciate you killing off the verify on the other screen. We know that's the 17-minute verify. We ran that.
Yep.
So to do a quick verify, I mean, I wasn't even, you were talking the whole time, it took like 20 seconds. So, I mean, it doesn't look like it takes that long and the resolution's pretty clean. Are you
Exactly.
able to, are you able to speak to like why that's the case? I mean, able to talk about the engine or why it's processing so much faster than other options?
Yeah, certainly. So, yeah, the engine, our kernel simulation engine was actually developed in-house by our developers. So I can't certainly take credit for it. We got amazing talent over there, and they do a great job at it. Obviously, a lot of our customers, kind of come to us and say, this is what, problems we're facing. And so we had the engine built in with our editor simulation kernel. We felt it could be of use if we tie that within Mastercam, and then it's kind of best of both worlds, of course, either as a standalone product of handwritten G code, or if obviously, right, we can push it out from Mastercam and do everything within the interface before the post processing, as if maybe that would take, perhaps a few minutes to post out the code, of course, too. So.
I would have taken credit for it. It's pretty slick, but it's not borrowed or leased technology. It's developed by CIMCO specifically to solve a Mastercam verification or to improve Mastercam verification.
Exactly. Yeah.
Now, this will also take you one step back. If a customer has a program that's written 100 years ago by a
Mhm.
software they've abandoned, and the guy that programmed it was 25 years ago, and last time somebody edited it was 20 years ago, it's sitting in the control. What can Backplot do to maybe give those guys a little bit of confidence? I mean, they don't have a Mastercam source file anymore to go
Right.
back and run simulation. I
Yep.
mean, they have an option with this as well, don't they?
They do, yeah. So they could even just use it as a plain back plotter by itself and just take a look at what the actual plotted code is going to look like. Certainly, you could add in different stock and fixtures, if you know what it's doing. But otherwise, we have a handful or quite a few customers actually that will take the plotted out code, save out that code as say like a DXF file or something that they could then use, and more or less reverse engineer it, bring that into Mastercam, and then at least they can maybe then recreate a source file, for that particular one down the road. So.
Yeah, no, I see a couple of our customers in the list here are currently using that feature. So shout out to Fluke Metals. But it's good to be able to take something somebody ran 20 years ago and to be able to know what it's going to do with some kind of confidence, right?
Right.
So
Right.
my thought now is it's cool. We've shown some 2-axis or some 3-axis stuff. We've shown a complicated mold. I'd kind of like to I don't know that we need to teach too much about it, but I want
Yep.
people to understand that full 5-axis simulation is in fact supported also. This isn't the rinky-dink Kia Rio of simulation. This is a supercharged Mustang, and I'd kind of like to just showcase that a little bit if you don't mind, Ryan.
Yeah, certainly. And yeah, obviously we recognize not everyone's running a standard, 3-axis mill or 3-axis parts, right? And so yeah, any 3 to 5-axis, 3, 4, or 5-axis is certainly supported as part of this, of course. So yeah, this is just a sample path that I had. Or part, I should say, going over some, actual true 5-axis simulation. Obviously, like Jason said, I'm not going to go ahead and actually go through the training portion of it. It would be the exact same process as those first 2 parts. And I'm also not going to bore you with actually doing the post-processing of the code either. So I did save us a little bit of time and steps on that, and going to, again, load that up within our side of things. So because I opened up that actual part itself, I can choose whether I want to do a backplot or a machine simulation by itself. The machine simulation, of course, is going to load in the actual machine models, and again, do all the collision checking and things of that nature. So in something like this, we could go ahead and kind of clean up that view a little bit and kind of get an idea of what's going on there. But same thing, we'd certainly be able to run through that by itself and kind of take a look at the, roughing of material and everything there like usual. In this particular case, I should have a bookmark down to some 5-axis stuff. And of course, you'll see the actual stock and everything update up to that point. And then, of course, we could certainly play that through and do some simultaneous 5-axis motion and movement for it as well. And you can step that, line by line if you want and actually see if there's a specific area of the part you want to check, especially with, maybe a rougher, up to this point, not being able to clear out these areas. Again, just different areas that we could, certainly do that with. So.
Sorry, go
Yeah,
ahead.
sorry, no, I was just going to say, and we have something called a reverse post processor. So, as a traditional post processor, Mastercam would generate the code. We obviously have one too that would actually read the code and know how to interpret that as well. So it's all obviously doing all those calculations live, obviously on the fly as well. So.
Well, and it is moving X, Y, Z, B, and C moves on this UMC 750. So I like that. This is not just some low-powered VF3 solution. It's a full 5-axis simulation.